So here we are. So our wind turbine is now a complete CAD model. So this is the Vestas data set, and we can see the complete finished nacelle. By the way, the nacelle is the box that sits on top of the pylon, and it contains a huge number of parts. It's a very dense environment for parts, and it's really important they are positioned correctly and efficiently. And we can see every little detail. So I can go down to nut and bolt level. I can look at the individual washers. I can take things apart however I like. We can go inside it and get a closer look at the data. So if we go inside here, what we were saying is these parts can now be assembled, these individual parts that you've approved, and put together as a larger model. And these models, these pieces of equipment are often made up with products that come from a number of different suppliers. So as an example, this generator could come from one supplier and come from let's say, a CATIA data set. This gearbox here could come from a SolidWorks data set. The rest of it could be out of PTC's Creo, for example, or Inventor, or teams out of Siemens NX. So you can mix all of these data sets together in one place. And then with those different data sets and different file types, you can actually grab hold of them and use your hands and move them around in the scene. You could work out whether that would fit in there or whether you've got a collision. You can see the colors changing as I'm colliding with parts. So you could do fit and test and access tests. In a fully tracked world, in a VR suite, we can even track real tools. So you could stand in front of that screen and use real spanners, real hammers, real drills to maneuver these parts. So this is really where it all comes alive. This is where engineers and marketers and customers can visually review all of their data in one place. And importantly, they all talk the same visual language. They've got a virtual prototype that appears real at one-to-one scale, which they can manipulate.